Securing data. How to make the data transmitted over the network or stored in the laptop or in any computer secure. Computer systems store and manipulate data, while communication system transfers data. What precautions can be taken to ensure that this data is not corrupted or intercepted by the wrong people? Let us example several techniques that can be used to make the data more secure. We will begin by introducing the basic techniques used to encrypt and decrypt data. Then we will look at some of the more recent techniques used to secure data, such as advanced encryption standards, digital signatures, public key infrastructure, and steganography. Steganography. Basic encryption and decryption techniques. And cryptography is the study of creating and using encryption and decryption techniques. It's called cryptography. Delivering into the topic of cryptography requires you to understand a few basic terms. Text, which will always be shown in lowercase characters in the example that follow. Plain text is the data before any encryption has been performed. It's called a plain text. Okay. Encryption algorithm is the computer. An encryption algorithm is the computer program that converts plain text into a ciphered and enciphered form. An encryption algorithm is the computer program that converts plain text into an enciphered form. The ciphertext is the data after the encryption algorithm has been applied. Ciphertext. A key is the unique piece of information that is used to create ciphertext and then decrypt the ciphertext back into plain text. After the ciphertext is created, it is transmitted to the receiver, where the ciphertext data is decrypted. All right. How are you feeling today? Plain text, encryption algorithms, and we have something else. This is called ciphertext. Early cryptography algorithms use the same key for both encryption and decryption. So they used to use the same key. The use of a single key greatly concerned many experts. In order to allow local and remote locations to send and receive the encrypted data, the key had to be given to both local and remote parties. If this key were intercepted and fell into the wrong hand, not only could encrypted data be decrypted, but false data could be encrypted and sent to either party. All right. So we have mono-alphabetic substitution-based cipher. Despite its daunting name, the mono-alphabetic substitution-based cipher is actually a fairly simple encryption technique. It replaces a character or a group of characters with a different character or a group of characters. Just replace characters. So whenever you see A, you put P instead. Wherever you see B, you put O instead. And wherever you saw O, you put G instead. And wherever you see P, you put F instead, and so on. So how about lunch at noon became something like that? Just replace a letter by letter. This is called Mono-Alphabetic Substitution-Based Cipher. This is the simplest way. The polyalphabetic substitution-based cipher is similar to the mono-alphabetic cipher, but it uses multiple alphabetic strings to encode the plain text rather than one alphabetic string. So it's poly, not mono. All right? Possibly the earliest example of polyalphabetic cipher is the Vigenère cipher, devised by Blaise de Vigenère in the 1586. Wow, that's in the 16th century. For the Vigenère cipher, a 26 by 26 matrix of characters is created as shown in the table. So it's 26 by 26. Okay, it just shifted. All right. To perform this cipher, you choose a key such as computer science, which you repeatedly place over the plain text message. For example, computer science, computer science, computer science. This is the key. Plain text becomes this. To encode the message, you look at the first letter of the plain text, T, and correspond the key character immediately above it, C. The C tells you to use row C of the 26 by 26 to perform the alphabetic substitution for the plain text T. Then you go to column T in the row C and find the ciphertext V. This process is repeated for every character of the plain text. The key computer science must be kept secret between the encoder and decoder. To make patterns more difficult for an intruder, the standard 26 by 26 matrix, row B, row A, row B, row C, and so on, does not have to be used. Instead, the encoding and decoding can be done using a unique matrix. In this case, both matrix and the key must remain secret, the matrix and the key. Transposition-based cipher. Transposition-based cipher is different from substitution-based cipher in that the order of plaintext is not preserved. Rearranging the order of the plaintext character makes common pattern unclear and the code much more difficult to break. Let us consider a simple example of transposition cipher. Choose the keyword that contains no duplicate letters such as computer. Over each letter in the keyword, write the number that corresponds to the order at which the letter appears in the alphabet when compared to other letters in the keyword. For example, computer C appears in the first in the alphabet, and C and E is second, M is third, and O is fourth, and so on. Take plain text, such as this is the best class I've ever taken, and write under the keyword in consecutive rows, going from left to right. Okay. To encode the message, read down each colon starting with the colon numbered 1 and proceeding through to the colon number 8. Reading :1 give us test V, and :2 give us TLEE, right? Encoding all 8 colons gives us the following. 2 interesting observations can be made about this example. First, the choice of the keyword is one given very important, and care must be taken into making sure the keyword does not fall into the wrong hands. Second, you could make the encryption even more difficult by performing an additional substitution-based cipher on the result of the transposition cipher. In fact, why stop there? You could create a very difficult code if you repeated various patterns of substitution and transposition-based ciphers, one after another. Public key cryptography. All the encoding and decoding techniques shown thus far depends on protecting the key and keeping it from falling into the hands of an intruder. Given how important the key secrecy is, it's surprising how often keywords or passwords security is lax or altogether non-existent. Consider the episode, and we keep going. Public key cryptography. It is also called asymmetric encryption. The opposite of asymmetric encryption is symmetric encryption, in which one key is used to encrypt and decrypt. So we either have 2 keys, and we call that public and private keys, or we have 1 key and we call that symmetric encryption, or 1 key is used for decrypting and for encryption and decryption. SSL is an additional layer or a software added between the application layer and the transport layer that creates a secure connection between sender and receiver because Unix operating system creates connection between endpoints in a network via sockets. The software has the title of Secure Sockets Layer, SSL. Successor is Transport Layer Security, TLS, which is based upon SSL version 3 and contains a few technical improvements over SSL. Another technique similar to TSSL is Secure HTTP or STTP, but it has not experienced the widespread success of TLS SSL. On the other hand, HTTPS is very important, is very popular, and remains one of the major security techniques for transforming secure web pages. Essentially, HTTPS layers HTTP over TLS. Thus, HTTPS is only as powerful as the underlying TLS protocol, while it was originally thought that both TLS, SSL, and HTTPS might eventually give way to IPsec, the newer security standard created by the Internet Engineering Task Force. This has not yet come true, that they are not all replaced by IPsec. This didn't happen yet. IPsec, or IP security, is a set of protocols created to support the secure transfer of data at the IP layer. One popular application of IPsec is in the support of virtual private networks, VPNs. Recall that VPNs create a tunnel between a user and a remote destination via the internet. IPsec uses encryption to protect the packet as it is transmitted through the tunnel. More precisely, the tunnel endpoints exchange public key, private key pair. So they do exchange keys, okay. Data encryption standard. DS is a commonly employed encryption method used by businesses to send and receive secure transactions. The standard came to effect in 1977 and was reapproved in the 83, 88, 93. The basic algorithm behind DES is shown in Figure 12.7. The DES algorithm works with 64-bit blocks of data and subjects each block to 16 level or rounds of encryption. Wow. 64-bit block of data. 16 levels of encryptions, 64-bit block of data. Even though a 56-bit key, 56-bit contains 16 levels of encryption, provide for more than 72 quadrillion possible keys, the data encryption standard was criticized from its inception of being too weak. Triple DS attempts to design a stronger encryption technique led to the creation of Triple DS. With Triple DS, the data is encrypted using DS 3 times. The first time is by the first key, the second time is by the second key, and the third time is by the third key. While this technique creates an encryption system that is virtually unbreakable, it is CPU intensive. That is, the use of Triple DS encryption requires a large amount of processing time. CPU-intensive process is not desirable on small devices such as cell phones, smartphones, and personal digital assistants, PDAs. Thus, what is needed is an encryption technique that is powerful as powerful as Triple DS, but also fast and compact. The AES, the Advanced Encryption Standard, answered this need. The AES was selected by the US government to replace DES. More precisely, the National Institute of Standards and Technology selected the algorithm Regendale, pronounced Reindol. This is pronounced Reindol. I don't know how, but it says here Reindol. Okay. In October 2000, as the basic of AES, the Reindol algorithm involves very elegant mathematical formulas, requires only one pass, not 3 passes like Triple D. Computes very quickly, is virtually unbreakable, and operates on even the smallest computing devices. With AES, one has the ability to select the key of 128-bit, 192, or even 256 bits. Data signatures. A data signature is a security procedure that uses public key encryption to assign to a document a code for which you alone have the key, digitally signed. Pretty good privacy, PGP. PGP or OpenGP. In efforts to create an encryption scheme that could be used by the average person, an entrepreneur named Philip Zimmerman created encryption software called Pretty Good Privacy, PGP, or OpenGP is high-quality encryption software that has become quite popular for creating secure email messages and encrypting other types of data files. PGP employs some of the latest techniques of encryption, including public key cryptography and digital signatures, and is available to anyone in the US for free. websites, FTP, and bulletin boards offer free copies for individual use, and commercial versions can be purchased for commercial installation. All right. Kerberos. Kerberos began as an authentication protocol designed to work on client-based client-server networks that use secret or symmetric cryptography. Unlike public key encryption, in which two keys are used, a public key and a private key, Kerberos used only one key for both encryption and decryption since its inception. However, Kerberos now also support public key cryptography. Public key infrastructure. Suppose that you are working for a company that wants to open for an internal local area network to the internet, so as to allow its employees access to corporate computing resources such as email and corporate databases from remote locations, to allow corporate customers or suppliers access to company records, or to allow retail customers to access to place orders or inquire about previous orders. In each of these transactions, the company wants to be sure that the person conducting a transaction is a legitimate employee or customers, not a hacker trying to compromise its system. A technology that helps a company achieve this goal is Public Key Infrastructure, or PKI. PKI is a combination of encryption techniques, software, and services that involves all the necessary pieces to support digital certificate authorities, and public key generation, storage, and management. All right, this is the public key infrastructure. Is a combination of encryption techniques, software, and services that involves all necessary pieces to support digital certificate authorities, and public key generation, storage, and management. A digital certificate, or simply a certificate, is an electronic document similar to a passport that establishes your credentials when you are performing transaction on the www. It can contain your name, serial number, expiration date, a copy of your public key, and digital signature of certificate issuing authority. Certificates are usually kept in a registry so that other users may look up a particular user's public key information. Many certificates conform to the X.509 standard, created and supported by International Telecommunication Union, Telecommunication Standardization Sector, ITUT. The X.509 standard defines what information can go into certificates. All the certificates contains the following pieces of information: the version, the serial number, the signature algorithm, the issuer name, validity period, subject name, subject public key information, and digital signature. The signature of the certificate authority that will be used to verify legitimate certificates. The certificate authority. All certificates are issued by a certificate authority. A certificate authority is either specialized software or network, or trusted third-party organization or business that issues and manages certificates. It's either one of these three. Certificate authority is either a specialized software on the network or trust a third-party organization or a business that issues and manages certificates. A certificate revocation list is a list of certificates that have been revoked before their originally scheduled expiration date. Why might a certificate be revoked? A certificate will be revoked if the key specified in the certificate has been compromised and is no longer valid, or the user specified in the certificate no longer has the authority to use the key. Companies that need to conduct secure transactions will often invest in their own PKI systems. What kind of applications or transaction would benefit from public key infrastructure? Here's a brief example: www, VPNs, emails, client-server applications, banking transactions. And to summarize this topic, here is a short paragraph. Steganography is the art and science of hiding information inside each other, seemingly ordinary messages or documents. Securing communications, making the communication secure. Spread spectrum technology, which is essentially takes the data to be transmitted, and rather than transmitting it in a fixed bandwidth, spread it over wider bandwidth. By spreading data, the level of security is incorporated, thus making the eventual signal more resistant to overdropping or wiretapping. Okay. The idea behind frequency hopping spread spectrum transmission is to bounce the signal around on random frequencies rather than transmit it on one fixed frequency. Anyone trying to eavesdrop will not be able to listen because the transmission frequencies are constantly changing. How does the intended receiver follow this random bouncing around of frequencies? It runs out of the signal does not actually bounce around on random frequencies. It only seems to do so. Analog signal, channel decoder, analog signal, PZ number sequences, transmitted scramble signal. All right, so this is called spread spectrum. Basic operation of frequency hopping spread spectrum receiver and transmitter systems. Direct sequence spread spectrum. Example of binary data that is converted into direct sequence spread spectrum and back. Guarding against viruses, signature-based scanning. Terminate and stay resident, monitoring. Integrity checking. Firewalls. A firewall is a system or combination of systems that supports an access control policy between two networks. The two networks are usually an internal corporate network and an external network, such as the Internet. A firewall can limit users on the Internet from accessing certain portions of a corporate network and can limit internal users from accessing various portions of the Internet. So just a wall, just like that, corporate and outside. Firewall efficacy. Some typical port numbers assignment are Telnet or remote login service is usually port 23. Finger, the service of finding a user's ID, is used port 79. Usenet, the newsgroup service, is often 119. Email port 25. Web browsing port 80. Basic firewall types: packet filter, proxy server, and application layer.